was 2 sine squared x minus 5 sine x minus 3 equals 0. Am I correct?
Yes.
Yeah.
At this point, we have to completely factor it. Without factoring it, we can move on. Let me know if you cannot see or it's blurry or something, okay? So can anyone give us the factored form of 2 sine squared minus 5 sine x minus 3 equals 0?
I have 2 sine x plus 1.
2 sine x plus 1 and sine x?
Sine x minus 3.
Good. So from here, we know that these give two options. So sine x equals -1/2 and sine x equals 3. This is the algebra part. Are we comfortable with that? Who gave us the factor form? Was it Derek?
Yes.
Thank you. Is this okay, everyone?
Yes.
Okay, in case you have any difficulties, no one is asking you to factor, just use the Corati formula and get sine x equals -1/2 and sine x equals 3, correct? Okay, so obviously sine x equals 3, how many solutions does this equation have?
Two.
Who said 2?
Gia.
Gia?
Yeah.
Okay, so let's talk about that. So this is the unit circle. And let me mute my participants. You are muted, so unmute yourselves when you speak. One more time, where do we measure sine?
Pi over 2 to negative pi over 2.
Where do we measure sine? On the x-axis or the y-axis?
Oh, y-axis.
Yes. How much? What is the top possible value of sine?
Pi over 2. Pi over 2.
The value, not what I can plug in it. What is the
One.
what is the maximum possible value that sine can be?
1.
1. So this equation has no solutions. There's no such thing. Sine is we say a bounded function. Its smallest value is -1 and his largest value is 1. The same thing with cosine. So they are bounded functions. Bounded functions.
Hey, Professor, really quick on that. So -1 and 1 is referring to the value itself, but then the angle would be negative pi over 2 to pi over 2, and then for cosine 0 to pi. Do I have that correct?
So we are talking about the inverse function now?
Or I guess the angle versus the value.
So x can be anywhere between -infinity and infinity. Anything that you can think of, you can plug in sine. Anything on the planet. Now, if we talk about the inverse function, it's a different story. Then we have to restrict the domain or the values of x. But in generally, if we don't talk about the inverse function, you can plug in x for sine and x for cosine, anything on the planet. There are no restrictions whatsoever. These are not functions with restrictions. They are like polynomial functions that have absolutely no restrictions. The result, the answer, whatever you plug in, it doesn't matter. But the answer could never be below -1 or above +1. The angle can be anything.
Okay.
Very good. Other questions? Okay, and then we have the sine x equals -1/2. And now we have to position the negative values. See where they are. Where are the negative values for sine?
quadrants 3 and 4.
Very good. So right here and right here. Perfect. So what did we say last time? Sine, what is the connection between sine x and 1/2? Forget about the negative symbol for a moment. From that little chart that we drew last time. So sine x connected to 1/2 always means that x is
5/6.
excellent. Well done. But since we are talking about an angle that has its terminal side in the third and the fourth, I have to divide these two quadrants by 3, pi over 6, 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 pi over 6. So then I always start from the x-axis, the positive side, and I have to end so that this is pi over 6. And again, I start at the same position, and I have to end where the reference angle is pi over 6. So this will be the second possibility. So sine x equals negative 1/2 has two options. Remember, this is pi right here, and here is 2 pi. So pi plus pi over 6, pi plus pi over 6, and the other one is 2 pi minus pi over 6. So x equals pi over 6 plus pi. I meant to write pi plus pi over 6. Sorry about that. 2 pi k. And x equals 2 pi minus pi over 6 plus 2 pi k, where k, we know it's 0, plus or minus 1, plus or minus 2, and so on. So then the options are 6 plus 1, 7 pi over 6 plus 2 pi k, and 12 minus 1. 6 times 2 minus 1. 11 pi over 6 plus 2 pi k. Any questions? Is this okay?
Yes, thank you.
Thank you. Moving on then. Finally, can we
I have a
start?
question.
Yes,
Is it wrong if you don't put 2 pi k?
we have to present all solutions.
Okay.
If we are asked to present only solutions in a complete rotation, which is 0 to 2 pi, we are restricted to 0 to 2 pi, we will find only pi over 6 and 11 pi over 6. If we're asked to find all possible solutions, there are infinitely many, because k is infinitely many, k has infinitely many values. Anything else? Okay, moving on then. Finally, let's start chapter 2. Chapter 2 deals with limits. It deals with where is my derivatives? It's a big chapter. So the first section that we are going to look at, it deals with basically the tangent and velocity problem. So 2.1 tangents. Tangents and velocities. They are determined in the same way. That's why they are together. And coming back to our situation, we have a function again. We have a point. Let's call it P again. Let's call this one Q. Exactly what we did. So I'm just going to jump into problems because this was already done last time. So if we're asked to find the average rate of change, that's not good. The average rate of change between P and Q, then we have y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. Of course, if I denote this by, so if P has x comma f of x, and Q is x plus h f of x plus h, then what do we determine? We're not really determining the average rate of change, but we are determining what?
The difference quotient.
The difference quotient. What is the difference between these two basically? Is this is the average rate of change. When we bring Q closer and closer to P, as you see, this kind of becomes the tangent line at P. Okay, so this is what the difference quotient is. Close, close. Okay, very close. We're gonna show that. And now I would like us to pick a problem and discuss how we determine. Now, here is the dilemma. So the dilemma is that if I'm given a point, let's say 1, 2, and I have a function, and I am asked to find the slope of the tangent line to f of x at p 1, 2. So that's our dilemma. Before we choose a problem, let's discuss this for a moment. So I'm given the function, I'm given a point, 1, 2, and now I'm asked find the slope of the tangent line. And you can say, not a problem. You have y minus y1, the slope, find the slope in the equation. The slope, x minus x1. And the problem is that I only have 1 point. With 1 point, I cannot find the slope. And if I cannot find the slope, I cannot find the equation. But basically, what I'm interested in at this point, we will determine the equation when we get the slope. But the question is, how do I determine the slope? I can't. That's my dilemma. I cannot. I only have 1 point. And the definition of the slope, or the formula, is y2 minus y1 over x2 minus x1. But I only have 1 point. So how will I be able to determine the slope of the tangent line, which has a very important meaning, which we will get to, which is, we already discussed it, is the instantaneous rate of change of that at that point, right? Why is this important? Why do I need to determine the instantaneous rate of change at this point or the slope of the tangent line? Because let's say I want to advise a product manager whether he should produce more units of a product for higher profit. I have to show him that if the rate of change of the profit is positive, then it's worth it. But if the rate of change of the profit is negative, he should not invest more and produce more units because his profit is not going to increase. So there are a lot of applications, infinitely many, of the rate of change of a function at a point. But my problem is that I cannot determine it because I only have 1 point. Here's the technique. Till we get to the easier technique, we have to talk about how we get there. So now if you'd like to choose, let's choose a problem. So where is my ebook? I got it. Okay. So we're looking at exercises 2.1. So please make sure you have the WebAssign ebook pulled up, so we can choose a problem and talk about it. Okay.
Start with number 1.
Number 1. Okay, let's do number 1. In number 1, in 2.1, we have a table, T in minutes, and V is volume. So a tank holds 1,000 gallons of water, which drains from the bottom of the tank. Let me share my screen for those who don't have this pulled up yet. So we have, sorry guys, I have to move you. A tank holds 1,000 gallons of water, which drains from the bottom of the tank in half an hour. Okay, the values in the table show the volume V of water remaining in the tank in gallons after t minutes, such and such. If P is the point 15, so I will copy because I have to switch to what I'm writing, so I have to copy them quickly. 100 and 250 and 444 and 694. Okay. We are given the point, and they're giving us 15, 250, that's P, on the graph of V. Find the slopes of the secant lines PQ when Q is the point on the graph with 5, 10, 20, and so on and so forth. Okay, and then we'll come back, okay, to the other parts. Okay, so I have the table. In order to determine the slope of the secant line, so this is our point P. So they want us to determine the secant line, the slope of the secant line between 5 and 15. So that will be y2 minus y1 over x2 minus x1. And let's just do one more, because I'm sure you understand what I'm trying to do. So let's do the 25. So this was between 5 and 15, and the other one between 15 and 25. So it will be y2 minus y1 over x2 minus x1, 25 minus 15. Is this okay with everyone?
Yes.
Yes.
Okay. So all I have to do now is plug these numbers in. I'm not going to share my screen with that because this is just too easy. So I have 250 minus 694 and divide by 10. And then the other one is 28. Don't forget parentheses. 28 minus 250. Close the parenthesis and divide by 10 again. So the first one, oh, why did the first one disappear? 250 minus 694. And let me know what you get. The first one I got negative 44.4 and negative 22.2. Without the measurement unit, it means nothing. So Kush, can you give us the measurement unit? Kush, are you here? Okay, Jordan, are you with us?
Yes, it should be gallons per minute.
Excellent. So remember, without measurement unit means nothing. And the measurement unit has to be a ratio. So back to our problem. Estimate the slope of the tangent line at P by averaging the slopes of two secant lines. So coming back, so I used intentionally, because I saw what the question was asking next. So this was part A, and now part B. So I used this point, and this point, and this point, so that I will average two equally distant points. So I'm not going to average 5 and 25, 5 and 15, this slope between 5 and 15, and the slope between 15 and 20. So I'm trying to have equal distance in the x values. So this is 10 distance, and this is a distance of 10 as well. Okay? So the slope of the tangent will be approximately negative 44.4 minus 22.2 divided by 2. So that is a negative 66.6 divided by 2, negative 33.3 gallons, of course, per minute. Is this exact? It's an approximation. It's an estimate. Back to sharing the screen. Use the graph of V to estimate the slope of the tangent line at P. This slope represents the rate at which the water... Okay. So exactly the same thing, but we just have to plot all these points and then estimate using... So this slope represents the rate at which the water is flowing from the tank after 15 minutes. Okay? So just plot the points. What I would do, you can use this... you can do it with a graphing calculator.